All right, so I put three problems that look pretty similar, right? They all have a sine, they all have an x, they all have a 2, right? But believe it or not, we're going to get three different answers, right? And all of these involve chain rule, okay? So, and the key to getting the correct answer with chain rule is identifying what your stuff is. And it's all in how you read it. So when I read this first problem, I look at this and I see sine of stuff, right? When you look at this, I see sine of stuff. And so when I take the derivative, well, what's the derivative of cosine?
Sine. Negative.
Sorry, what's the derivative of sine?
Oh,
Cosine, because we're going to take the derivative of these, right? So when I take the derivative of this, I get cosine stuff, right? Oh, actually, I should probably change the colors. But I said the word stuff, didn't I? And since I said the word stuff, I have to take the derivative of this. And what's the derivative of the 2x?
Just 2.
Just 2. And so the derivative of this thing is this. Of course, if you look the answer in the back of the book, they're going to say it's 2 cosine of 2x. All right? We okay with that? All right? Next up, let's look at problem 2. I want to take the derivative of this thing, so d dx. And when I look at this, I see sine of stuff. Can you look at this and see sine of stuff?
Yes.
Okay, there's our sine of stuff. And so this is so now we think, well, how do we take the derivative of sine of stuff? Well, what's the derivative of sine?
Cosine.
Cosine.
2x.
So no, I do cosine, copy stuff. Your stuff is x squared, right? Because if you say the word stuff, I see sine of stuff, the derivative of sine of stuff is cosine stuff. And I said the word stuff, so I'm using chain rule, so what's the derivative of that? 2x.
Okay.
And if you look the answer in the back of the book, they would probably write it as 2x cosine of x squared. So believe it or not, the first two problems usually don't cause any real issues. It's the third problem that causes all the issues. And the reason this causes all the issues is some horrendous notation that if I could get rid of it, I would. Right? And actually, for the next couple of weeks, you need to get rid of this notation until you get super comfortable with it. Because somebody, a few hundred years ago, decided that instead of that writing sine of x squared was too much work. So instead of writing sine of x squared, they said, well, why don't we write it this way? And what happens when that person introduced that notation, they pretty much confused at least 75% of my high school students. Because if I give you this problem, and I say take the derivative, I get the right answer 100% of the time. But when I write it this way and I give you the problem and I say take a derivative, I get it right, I don't know, I'll start off at 50%. By the time I'm done with you, it gets up to better, right? But if I give it to you this way, nobody misses it. But when I give it this way, I have a significant percentage of students who do miss it. Meaning, I hate this notation. I can't get rid of it, so I have to make sure you understand it. So, let's look back at this problem. How do we take the derivative of sine of x squared? When I look at this, I see stuff squared. Do you see stuff squared?
Yeah.
Right?
Yeah.
When you look at that, if you see stuff squared, right? So when I take the derivative of this, that's going to give me 2 copy stuff to the first. But I said the word stuff. Right? And anytime I say the word stuff, that means I have to take the derivative of stuff. And what's the derivative of stuff?
Cosine.
Cosine x. And so it turns out the derivative of this is equal to 2 sine x cosine x. All right, so let's just look. three problems that look pretty similar.
Yeah.
But notice we've got three different answers. In fact, these two problems look very similar.
Yeah.
But we have two completely different answers. And therein lies kind of an issue whenever, kind of the problem when we start doing chain rule with trig functions, things get very interesting very quickly. So now, here's what I want everybody to do at home. So here, like question 4, I held off on question 4. I want everyone to take the derivative of sine squared x squared. Here's how you need to look at this, right? Very important. It's like the way you approach, like where your eyes focus is what makes, how you look at the problem makes a huge impact on if you get the right answer or not. All right, so I look at this, this means sine of x squared squared, right? That too means this whole thing squared, right? And so when I look at this, what I see is stuff squared. Can everybody see this is your stuff, right? Squared. So when I take the derivative, this is going to give me 2 stuff to the first. I'll go ahead and write down what my stuff is, which is sine of x squared. This is my stuff, so I've got to take the derivative of this. And when I look at this, I see sine stuff. Do you see sine stuff?
Yeah.
And so our derivative of sine stuff is going to be cosine stuff I'm running out of colors. Sine stuff, right?
Mm-hmm.
And so then I do cosine stuff, but I said the word stuff, didn't I?
Yeah.
If I keep saying the word stuff, now I have to take the derivative of that.
Uh-huh.
And so the derivative of that is going to give me my 2x. Of course, when I simplify this whole thing, I end up with 4x sine of x squared cosine of x squared. I got the 4 from the 2x, 2 times 2x. And then I just copy this part down, and I copy this part down.
I just took, I guess I did that incorrectly. I took the derivative of sine x squared, I just put 2 cosine x.
No, because you have, when you look at it, you have to see, oh, this is stuff squared.
Okay.
You have to look at that first.
Okay.
How do you take the derivative of stuff squared is 2 stuff to the first.
Mm-hmm.
Then you said the word stuff.
Again, inside.
And anytime I say the word stuff, that means I have to take the derivative of this thing and stick it out here. When I look at this, I see sine of stuff again. So that gives me cosine. Oh, I said stuff again.
Yeah.
And then the derivative of that gives me 2x.
Okay.
See how it gets a little more complicated? See, at least in problem 33, they were very obvious that you had it multiple times because they had all these different parentheses. With trig functions, they hide it, right? Because they could just put numbers anywhere, and somehow that creates another level of chain rule. All right. Let's try it one more time. Example 5. What if I give you 1 over the square root of sine x squared? Actually, so first, your first hint is you don't like it this way. You want to rewrite this as sine of x squared to the negative 1/2. All right, so now that we rewrite it, the first thing I notice is I see stuff to the negative 1/2. Now, if I see stuff to the negative 1/2, that means when I take a derivative, I get negative 1/2, and I'll subtract 1, it gives me negative 3/2, right?
Yeah, now.
Good. Right?
Yeah.
So I see stuff to the negative 1/2, so I know it's going to be negative 1/2 stuff to this, right? And when I say stuff, that's the stuff I'm talking about, so I'm going to go ahead and write down the sine of x squared. Now, since this is my stuff, I have to take the derivative of it. And the derivative of sine of x squared is, well, I see stuff again. So the derivative of sine is going to give me cosine. I'll go ahead and copy the stuff.
Mhm.
I said stuff, and so now I got to take the derivative of that, which is going to give me a 2x.
Oh, I see.
And now there's the cleanup. This 2 cancels this. This is going to go on the bottom. That's going to go up top. So I get a negative on top. I get cosine of x squared of, oh, I'm also going to get an x. And then I'll end up with sine of x squared all to the 3/2, which most likely, if I were to look up in the back of the book, they would say this is equal to negative x cosine x squared all over the square root of sine of x squared cubed. Yay, right?
No.
No, right? When you start putting, when I throw trig functions in here, and what I probably should have done before I gave you this before I started doing these examples, is modified my derivative chart for trig functions. So I'm going to talk about them. All right, this is where it's killing me with board space. I have this giant board over here that I would just put formulas that I can't really do. So let's refresh our memory on derivatives of trig functions. Right? So I have like the derivative of sine is equal to cosine our derivative of cosine is equal to negative sine, and derivative of tangent is equal to secant squared, derivative of cotangent is equal to negative cosecant squared of derivative of secant is equal to secant tangent, and derivative of cosecant is equal to cosecant cotangent. All right, now, I don't know if you noticed, but I changed the x's to u's, and the reason I need to change the x's to u's is kind of, that's pretty much, that's what every textbook does. And the way I want you to think of a u is I want you to think of it as stuff. Like when you look in your textbook, does it have them? Yeah. Particularly if you look in, no, it doesn't have the calculus stuff. I don't know why they took it out. Oh yeah, they do have them. If you look at the front cover, oh, well, never mind. You don't have a textbook, that's online. But if you ever look up trig identities or stuff anywhere online, they usually have a chart that looks very similar to this. And I don't know if you've noticed, if you looked it up, they don't really have x's, they have u's. And the way I want you to look at a u is I want you to think of it as stuff. So we're going to modify our, like I had x's, when we did this a couple of weeks ago. But when you have the u, if you think of that as stuff, then its derivative of sine stuff is cosine stuff times derivative of stuff. Because remember, you doing chain rule. Your stuff just happens to be the u.
Okay.
If it makes you feel any better, and the same thing here, derivative of tangent stuff is secant squared stuff times derivative of stuff. Same thing here, derivative of secant stuff is secant stuff, tangent stuff times derivative of stuff. Same thing over here, times derivative of stuff, times derivative of stuff, times derivative of stuff. Other notation they use to talk about derivative stuff, sometimes they'll say like u prime. A lot of times they'll actually say like du representing derivative of stuff. du, 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 right? That's like the official way of doing it. Here's how I teach it. I'm not going to change it for all of them, but I'll change it for a few of them. So if you have the derivative of sine of happy face, that's going to equal cosine happy face times the derivative of happy face. Where whatever's here, that's your stuff. And so the derivative of sine stuff is cosine stuff times the derivative of whatever the stuff is. Right?
Right.
I don't want to draw the happy faces for all the u's, but I hope you get the idea.
Yeah, that makes sense.
Okay? So this is our modified, this is the official derivative of trig function chart. Right?
Isn't cosecant the derivative?
Yeah, negative. Thank you, I forgot the negative. Derivative of all cofunctions is negative, yes. I was in a hurry, left off the minus, all right. But, all right, so we get the idea. Now, so how does that impact, does that mean that using chain rule with these other trig functions is harder? Unfortunately, yeah, it does mean. Okay. There are a couple of places where students tend to mess up, and so I want to make sure that we do some examples of that. Actually, before I do that, let's just do one more to make sure we at least have the stuff with sine and cosine down. So if I give you y is equal to cosine cubed of 4x, I want everyone to find the derivative.
Wait, if it's just cosine 4x, do you consider the 4x stuff?
Yes.
Okay.
Good. So to do this, the first thing you do is say, all right, well, this is going to be cosine of 4x all cubed. So I see stuff cubed. That's 3. Copy stuff, which is cosine of 4x squared, times the derivative of the inside, which is cosine stuff. So that's going to give me a negative sine 4x. Okay?
And then just...
And then there's stuff, so then I have it times 4.
okay.
And now to clean this up, that's technically a negative 1. So if I were to look the answer in the back of the book, they would say this is negative 12 cosine of 4x squared times sine of 4x. This is not a subtraction, right? This is times negative because we're multiplying.
Right.
All right. So that's with sine and cosine. What happens with the other trig functions, right? Well, for the most part, tangent and cotangent are okay. For example, if I gave you y is equal to cotangent of 4x squared minus 3x. When I look at this, I see cotangent stuff. Everybody see cotangent stuff?
Yeah.
Right? So the derivative of cotangent stuff is negative cosecant squared stuff, which is 4x squared minus 3x. But I said the word stuff. And anytime I say the word stuff, that means I've got to do chain rule. And so that's going to be, 8x minus 3. And so here's my answer, right? Just kind of what was happening with sine and cosine. Most students don't miss a question where I ask you for the derivative of cotangent or a derivative of tangent. You just got to remember it's, cotangent is cosecant squared stuff. You write down the stuff, and whatever your stuff is, you take the derivative and put it here. Right? This next, the issue is going to be with secant. So I've got 5 minutes. I'm going to talk about secant. So what if I had given you y is equal to secant of 3x squared plus x?
is,
Okay, so if you think about the rule, right, our rule was the derivative of secant is equal to secant stuff tangent stuff times derivative of stuff. Like if I do my little happy face analogy, derivative of secant squared stuff is equal to secant squared stuff tangent squared stuff times the derivative of stuff, right? Notice the stuff's repeated, right?
yeah,
That's a big deal. So when I take the derivative of this, derivative of secant stuff is equal to, here's my stuff. It's equal to secant stuff tangent stuff. I'm going to copy the stuff here. I get 3x squared plus x, 3x squared plus x, times the derivative of stuff, and so the derivative of stuff happens to be 6x plus 1. So whenever you take the derivative of secant, you have to copy your stuff down twice, which gets confusing because you're not used to, right now you're just saying, wait, I'm just getting used to writing the stuff down once. Why do I have to write down stuff down twice? And it has to do that the formula for secant is secant, derivative of secant stuff is secant stuff tangent stuff. The stuff gets repeated.
And then leave the answer label.
Yeah, there's nothing we can clean up because each of these is sort of stuck at that point. All right. I've got time for one more example. I really want to do two, but 45-minute class periods and doing it online really cuts down the examples you can do. So I'm going to start with y is equal to x, secant squared x squared plus x plus 1. Give everybody a chance to write it down because I've got 4 minutes and I think this is going to take about 2. All right, so when I look at this, what's the first thing you see you have to use?
you have to, okay,
What do I have to use?
you have to square everything, kind of.
Whenever I draw that line, what does that mean you're using? Product rule. Do you see we're multiplying two things that have an x? This has an x, and this term has an x.
Mm-hmm.
Anytime you're multiplying two functions, right, that have x in it, you have to use product rule. And so product rule is derivative of this, which is 1, copy stuff, which is going to give me secant squared x squared plus x plus 1, plus,
Good morning, teachers. When the bell rings, you will dismiss half of your class.
yeah, I know, come on.
Students, you will report to flex period. Please continue to wear your mask and remain socially distanced. Again, once the bell rings, please release half of your class. Thank you.
Yeah, that's fine.
So that squared means that's squared. So now to take the derivative of this thing, it's 2, copy stuff. So this is 2, I'm going to copy whatever ugliness this is, which is going to be secant of x squared plus x plus 1 to the first. But since I copied stuff, I have to take the derivative of this, which is, derivative of secant stuff is secant x squared plus x plus 1, tangent, oh shoot, x squared plus x plus 1 times derivative of stuff, which is 2x plus 1. And see, this is, if this is f and this is g, this whole thing is g prime.
Whoa.
Times f. I'm not going to make you clean that up. That's just hideous. So you product rule on that part. All right. So your homework.